All right, for today, it's about graphing logs and exponentials. But first, we need to kind of get the big picture on what is a log. What are we doing here? What if I had 5 to the x equals 14? Would you agree that 5 to some weird decimal probably gets to be 14? Well, how do we get that weird decimal? 5 to the 1 is too small, because that'd be 5. 5 to the 2 is too big, so it's clearly 5 to the 1 point something. How can I get that? With a log. Everybody write this out as a log. Log base what of what equals what? Carmen.
Log base 5 to the 14.
Of 14.
Of 14, sorry, is
Good.
equivalent to x.
Very good. Okay. So log base 5 of 14. That's some weird decimal that's a little bigger than 1 and a little less than 2. Okay, so now what do I do? Well, you judge which one's better. Do you like the black version of it? The black form of this equation? The one that says 5 to the x equals 14? That's called exponential form. Or do you like the red version of it, which is log form? Well, how do you judge which one's better? Which one's closer to being solved? Solved means x is alone. And in this case, it's a no-brainer. The red one's better. Okay, because the red one's solved. It's got x alone. All right. So, could you do that when it was more complicated? X plus 6 to the third is equal to 14. Totally different question. Write a log problem for that. That cell phone is saying, please put me in a backpack where I'll be safe and not fall on the floor. Just put it in your lap. All right. This should be log. Base what? Base x plus 6 of 14 equals 3. So now which one's better? Top one's actually better. Is that top one always better? No, this time, last time the log was the better form. This time, this is better, because I could see the steps to solve it. I just have to put it to the power of, do you remember? 1/3. And then subtract 6 and I'd be done. See what I mean? So that's why we use these different forms of the equation, is to solve stuff. We're trying to get the x's alone. So you got to be able to go back and forth between logs. All right, so here's a few other log things as you should know. What if I said log base 2 of 2 to the third? I know the answer. Do you know the answer? It's 3. And if I say, I don't know what the answer is, I'm going to say it equals x. Then you could go 2 to the x is equal to 2 to the third. This whole thing's like a chunk. And then this makes it pretty obvious that the x must be 3. See? Okay. So here are 4 of them that I'd want you to be able to do on a regular. If I said log base 3 of 3, that should be super easy. I'm not even going to do that one. I'm going to say 3 to the third, just to make your life confusing. Log base 3 of 9, log base 3 of 0, and log base 3 of 1. What's that? What's that? What's that? And what's that? That's 4 of them. And we're going to call them A, B, C, and D. Would you please compare A, B, C, and D with the kid sitting next to you? You might know some of them, you might not know some of them. Maybe they'll be able to teach you something. I'll pause for a second. We can figure out those 4 answers. This should have been pretty easy. As long as these 2 bases are the same, then the power's right here. And so then the answer's 3. The answer is the power if the bases are the same. I can make this so they are the same by saying 3 squared. And then all of a sudden, the power becomes the answer, 2. For letter C, when there's a 0 here, there is no solution, but even better than that, it's the asymptote. If you said no solution, you weren't wrong, but did you also know that when this part gets made 0, you found the asymptote? And then last but not least, when you've won the argument, you get 0. You get nothing for the 1 in the argument spot. I gave the example of, let's say, I argue with my wife over something stupid like pepperoni versus sausage. And maybe I'm better at debate, and so I finally end up backing her in the corner and proving that sausage is better than pepperoni. You can win the argument and get nothing and just have somebody mad at you, and it's not worth it. So, life lesson, and going to come up in this class a fair amount. If you have a 1 in the argument, you get nothing. All right, are there any of those that you don't understand? You want me to clarify, A, B, C, or D? Okay, then let me show you one more like C. Log base 4 of x minus 7. What number could you put in here that would work well? Well, what do you mean by work well? Well, one thing I'd like to find is the asymptote. What number could you put right there in the XY chart that would give you the asymptote? I tried to show you before, but I don't know if it's stuck or not. It is 7, because if you put a 7 here, I have 7 minus 7 here, I get a 0 here. It means not only does it not work, if it specifically equals 0, you found the asymptote. Do you get if I put a 5 here, it still doesn't work, still no solution, but it doesn't give you the asymptote because it doesn't make exactly 0. See, this needs to make exactly 0 to get you the asymptote. So a 5, also no solution, but doesn't give you anything special like the asymptote. Okay, now let's find a few more points. Would everybody please put in the numbers 8. And actually, I'm going to let you try to figure out one more good number to pick that will give you a nice point. Please do put in 8, but then you figure out a wild card. Put in anything you want, but something that'll work nice. And in a moment, again, I'll ask you to compare with the kid next to you. And here we go with putting in an 8. I'd like to know, Mr. Velour, what did you get when you put in an 8?
I got a 8 or 0.
And that was a 1, so you had log base 4 of 1. What's the rule on that?
The 0, I guess, was in 0.
Yep. If you won the argument, you get nothing. Good. All right. What's another thing that you picked, Joel?
I picked 11.
Why did you pick 11? I know it wasn't randomly.
I picked 11 because 11 minus 7 is 4.
And then that would be 4. And then you got log base 4 of 4, which works out to what?
1.
So my point would be 11 comma?
1.
Yep. Now, is 2 points really good enough to get a curve going? No, it gives you a straight line, but it doesn't give you a curve. So, let me talk through strategy on what do you do then to get that last point. We had an x minus 7 here. Well, first thing you do is try to make it the same as the base. So 4, that makes sense. Another thing you could make it is, what if it was, when we were done with it, log base 4 of 1/4. I want you to process that for a second. If it's log base 4 of 1/4, do you get that would come out to -1? Because the 1/4 would be like 4 to the -1. Do you get how that would come out nice? Okay, so how could I get this to be 1/4? Well, then you just say, I want this to be 1/4. X minus 7 equals 1/4. You add 7 to both sides, you get 7 and 1/4. You can put in 7 and 1/4? Yes, you can. Because you know it's going to work out so nice. See, when I put in 7 and 1/4 here, 7 and 1/4, 7 1/4 minus 7 is 1/4. Log base 4 of 1/4 works out nice. Works out to -1. So that would have been a cool option. Did anybody else think of another point that would have worked? Yes.
23.
Ooh, I'm guessing that wasn't chosen randomly.
No, because 23 minus 7 is 16.
So if we put a 23 right here, 23 minus 7 is 16, and log base 4 of 16 also works out nice. What is it?
2.
It's 2, because that's like 4 squared. So 2. Look at how many points we can get. All right, let me make sure you really caught that. This is going to happen all the time. You have log base 3 this time of x minus 5. I'd like you to figure out the asymptote and 3 points. Asymptote's already done. Liam, how to find the asymptote? 5 gives you the asymptote. Why? Because it makes this part equal 0. Three other points. I would like you to, you just got fresh off of doing a group test, and remind me if you would at the end of the hour, and I'll happily hand back those tests to those of you that haven't seen them yet. You just got done working in groups. Why don't you guys work in groups to find 3 points? Maybe you've already got 1 or 2, and then you can work together to find the third one. Turn and work with the kid next to you. Okay, let's hear what your group said, Toby.
You said for one of them 8.
8, and that works out to log base 3 of 3, which is 1. And what else did you pick?
14.
14 minus the 5 makes log base 3 of 9, which gives you 2. And give me one more.
5 and 1/3.
Ooh, fancy. So if you put in a 5 and 1/3, you'll get, wait, 5 and 1/3, you'll get log base 3 of 1/3, which then is really the same as 3 to the -1. So you get 5 and 1/3, comma, -1. I don't think it could have done any better. But there might be a different point. Who has a different point? Carmen.
We have something about 6 and 0?
6 comma 0 works great. So
Why?
why? Okay, so we put a 6 here, and then you get 6 minus 5. What's 6 minus 5?
1.
And then you've got log base 3 of 1, and you've won the argument. Whenever you won the argument, you get nothing. You get 0.
Right.
All right. That was a great add-on. I love it. Okay. Do you get the graphing logs is not that bad if you can find points on the XY chart? Okay. How about graphing exponentials? That's the only other thing we have to cover. So what if we have an exponential like, what does an exponential look like? It looks like this. Y equals, hold on. Yes, they have a Y equals at the beginning of them.
Oh, okay.
If you're, yep. Because that's what these are, is Y values.
It's like something equals something that equals something. That's weird.
Yeah. Oh, okay. So this is just a function. It's kind of like x squared plus 6. Logs are functions. So, all right. So anyway, yes, it's y equals. Say I said 5 to the x. First of all, you have to know exponential growth looks like this. Then you have to know if I decide to play around with it and like say, let's add 2 up here in the exponent. Do you get it would move? You'll go 2 to the what? 2 to the left. What if I say plus 7 on the outside here? Then that's going to move where? Up 7. Do you get how this is different than this? And it's subtle. Both of them are on the right side of the function, but one of them's in the exponent and one of them's not. So this is up, and that one would be left. Okay, next, let's say I want to actually get points that are on this crazy looking function here. Once again, XY chart. Once again, choose wisely. Why would 2 be a really bad call? Because then I got to go 5 to the 4th and then add 7. Holy crap, that's huge. Don't want to do 2. I want to do numbers smaller than 2 for sure. Like what? Like maybe, how about 0? Everybody try putting in 0 and -1 and -2. And then figure out one more thing. I'll ask you to do these 3, but find one wild card that isn't x equals 0 or x equals -1 or x equals -2. One more wild card. I'll pause for a second while you give that one a try. We're graphing exponentials now. So you just put in 0, which is right here, and then you got 5 to the 2, which is 5 squared, which is 25 plus 7, 32. I agree. 0, 32. All right. Justin, did you put in one of those numbers?
Yes, I put in -1 and 12.
-1 here makes it 5 to the first, which is 5, plus 7 is 12. I agree with you. All right, how about the -2? Crocker.
For -2, I got, that's
Good. Some people think the first number is 0, but 5 to the 0 is 1. 1 plus 7 is 8. And then there was the wild card point. St. John. Did you make up a wild card point? All right. I'll take a volunteer for this one then. Robbie.
I just took 132.
Oh, okay. It's kind of big, but yeah, there's nothing. You're not wrong. If I put in a 1 right there, I get 5 to the third, 125 plus 7, 132. Okay. Did anybody find a smaller one? Okay. So, what could you have done? Well, this one's tricky because of that plus 7 on the outside. It makes it harder to like find good options. But what if I had made this power come out to a 5 to the -2 plus 7? Do you get how that wouldn't be that hard? What is 5 to the -2? Well, I like to think of it as 5 squared, 25, and then you flip it, so it's 1 over 25. So that would be plus 7 is 7 and 1/25. So how do you make this -2? You'd put in -4. Not saying that would have been the best point in the world, just saying it would have worked. -4 goes in, and we get 7 and 1/25. Just showing you lots of points because that's the hardest thing today. Or graphing. Okay, and then the last thing I have to teach you. Do you remember finding inverses? Let's find an inverse of just that. That's not an exponential and it's not a log, but we'll do those in a minute. But how do you find an inverse again? This is an example of a question on your final. We have a final? Yes. But the final doesn't count as a final. I'm going to pause for a second. So let's see if you remember x equals y plus 3. What just happened? X turned into y turned into x. That's what you do with inverses. Why are we even talking about this old topic, Mr. Server? We learned this a long time ago. You know, I could say equals y, or I could say y equals, and I prefer to say y equals. There we go. Because logs and exponentials are inverses of each other. Here's a log graph. Here is an exponential growth graph. And they're a reflection across the line y equals x. Look at that. They're a reflection, which makes them inverses of each other. So log, that's this one. Log base 2 of x, for instance. And this one, which would be y equals 2 to the x. Those two are inverses. When you switch their x's and y's around and you solve them, you could then rewrite the 1 to become a log, and the 1 could be rewritten and it would become an exponential. So they're inverses. So you have to be able to take one that's like this. Do you agree that that's an exponential? And one thing you have to be able to do is rewrite it as a log. That wouldn't be that bad. But another thing you have to be able to do is make it have its inverse. All right, first, would you rewrite this as a log? It'd be log base this of that, you know, just make a log. Yes, ma'am.
How can this exponent be equivalent to a log, yet they're inverses of each other? How can they be equivalent, but they have completely different graphs?
I didn't say they were equivalent. I said that they were inverses of each other. Okay,
Yeah, but
so,
the fact that you can rearrange it to get the same answer.
okay, just rearranging this, just to clarify, to rearrange this does not make it the inverse.
Oh, okay.
This is just rewriting this. So this would be log base 5 of y is equal to x. Okay, and these two are just rewritten, and like you said, they're equivalent to each other. Those are not inverses of each other. If you want an inverse, then you'd have to switch x, y around, and let's do that. Everybody take the same equation, the red one, and switch x and y around, and then solve it. Hint, you're going to need a log to do it. The first part's pretty easy. X equals 5 to the y. And then you might be like, duh, how do I solve that for y? Maybe since this whole thing is about logs, you should rewrite it as a log base 5 of x. And I could say equals y on the right side. I prefer to say equals y on the left side. And there we go. Look at that. That and that are inverses of each other because I switched the x and y around. And then I solved it. Okay.
So switch the x and y around in the log too, and that'd be inverse.
But remember, okay, so in other words, let me rephrase your question to this because the kids will have to know this. What if I had log, y equals log base 4 of x, and they said, make an inverse of that? We can do that. We switch the x and the y around. X equals log base 4 of y, and then that looks weird because the y is on the inside, right? So then I could solve it. How do you solve that? Usually it's all about, if it has a log in it, you want to get the log out of it. So let's get the log out of it, and then it would be 4 to the x equals y. And I solved it for y. Yay. That is the inverse of that. Because here I flip-flop my x and my y, and then I solved. So these two are inverses. Okay, let's actually look through the notes here quick. We're down to the last 15 minutes of class. Now, I know that one thing I didn't mention was about exponential growth versus exponential decay. So I want to look at that quick. But let's look at problem 7 here. It's probably a kind of a good, not a super easy one, but an average one. If you had to graph that, here's a few things I would hope you would know. Everybody just sketch quick, what's log look like in the first place? This is an ln, which is a log base what? E. Good. Tell somebody watch the video. Log base E is log base E That's about 3. Remember, E is about 2.7, which is pretty darn close to 3. So it's pretty much like a 3. I know, I'm rounding there, a fair amount. But that's good enough for a sketch. Otherwise, you'd need a calculator to get super close, because it's technically 2.718, dot, 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 keeps going. All right, so if I was going to graph this, I hope you know logs generally look like that. Have you got that much out of this today? That's what a log looks like. Except this one's been flipped vertically. Can you handle this kind of flip? And what's that mean? Up 2. So if I move this whole thing up 2 spots up. Now you might be like, that's a little vague, Mr. Server. How about some exact points? Well, and I'd say make an XY chart. Tanner, give me a number to put in. And be strategic. I don't want you to just say a random number. That's not a bad call. Because this is like having a log base 3, and then he said put in a 3 here. That's pretty smart, because then this would equal approximately 1, and then you put in a 3, and then so far we've got -1 plus 2, which would be 1. And this is approximately 3. One more thought on that. Technically, the 3 isn't 3, right? It's a little bit less than 3. Okay, so when you're graphing, you just understand it's not going to be perfectly exactly at 3, 1. Okay, what's another thing we could put in? Well, some kid might say E, because this has a base of E technically. And then wouldn't it be nice if that was an E? Log base E of E? Well, that's pretty much the same thing as this, because E is pretty much 3. You know what I mean? So you could handle it 2 different ways. You could either say, I'm going to put in E, and I'd get 1. Or another kid might say, well, I think E is pretty much 3, so I'm going to put in 3. And you still end up getting 1. But this is actually more accurate. Okay. What else can we put in? 1, and if you won the argument, you get?
0.
Yes. Does the whole thing become 0? No, this part becomes 0, and -0, of course, is still 0. So 0 plus 2, I put in a 1, and I get 2. Okay, I hope you get the idea of finding points on your graph. That's the biggest thing. Now, if I were you, and I was thinking about homework, I know some of you are like, not doing any homework, I'm doing fine. If you're not doing homework and you're doing fine, then you've got good enough grades that I can't really say you need to do this, or you won't believe me because you've been doing fine without it. But I think you'd find if your grade is anything other than an A and you haven't been doing much homework, it would make a surprising amount of difference. If you would just do a few problems on each page, it would make a surprising amount of difference. You might be like, dang, the next test went really well. Try it. Okay, so if you've been a kid faithfully doing homework all along and getting straight A's, I would keep it up because this is working for you. If you're getting a B or a C and you're not doing homework, well, that's the first thing you'd want to start. All right, so I'd try this one. And if these felt really hard to you, I might have started with the easier one, whatever. Then I'd try this one because you definitely need to know about E, the natural logs. That's why they have pictures of logs in the background there. Probably don't need to do this many. I would say just do this one. And then start with this parent graph and then move it. In here, this is find the inverse. Remember how you switch X and Y? That's really Y equals. And then you switch X and Y. And then you have to rewrite it as a log and solve it. That's the algebra stuff. If you have algebra issues, you should practice that. Something that we're going to expect you to know how to do. This one, it doesn't have any base on the log, and some people get confused by that. Do you remember what the base is if there is no base? It's base 10. And then basically they give you a number that you can put here, and they encourage you to use a calculator. And then if you stick a number in here, you can figure out this, or vice versa. Same thing here, this is Richter scale, because logs are what you use to make the Richter scale, and decibels, those two things. The previous one was Richter scale, sorry, this one's decibels. And again, no base, so I know it's base 10. And the intensity goes here. And again, something that leans towards using the calculator, unless they give you nice numbers, which they do. They give you like 10 to the power of whatever. Or if I want, I can say, I want my decibels to be this, and then I can figure out and solve for the I. So don't be scared of the word problems. You basically just have an equation you're given, and then you stick a number in either here or here. All right. So that's the last example is of pH. That's another real life log example. Logs are used in pH. It's like I tested the pH of my water at my house the other day, and I was at 6.5. What's normal? 7. So if my pH is less than 7, then that means my water is slightly acidic. It's not terribly, yeah, but
It's like a 2.
But every time you drop a whole number on the pH scale, you're dropping a factor of 10. So if you go from a 7 to a 6, then that's 10 times more acidic than it's supposed to be.
Well, just like tap water?
Tap water. Yep.
I'm not drinking that.
So bottom line, pH, Richter scale, and decibels. They're all good examples of logs in real life. Okay, now we're at an important moment. We have 3 kinds of kids again. Kids that are fine right now, you've understood everything I've been teaching and you're good. Kids that are lost right now and are not going to do anything tonight and are just going to come back tomorrow and get even more lost. And kids that are lost right now and are going to take some time right now to figure that out and get caught up because you missed Friday and maybe you didn't watch the video and then this was confusing because you didn't know about Friday. And take the time, please. This is your last big test. We're just starting this unit, and you don't want to be completely lost at the beginning of the unit and then end up bombing your last big test, other than the finals. All right, that's all I have for you for today.